Another method of solving systems algebraically besides substitution is with elimination. So we're going to have some different steps here. With elimination, first thing we're going to want to do is make sure that both of the equations are in standard form. And we kind of want to line them up nicely so that the x's line up, y's line up, and then our constant on the other side of the equation. So like all of these, I believe, yep, all of these are all set up with that first step done for us, where we kind of have them all lined up so that vertically we can see our x's, y's, our equal sign, and then constants on the other side. Okay, if necessary, we can multiply either equation or both of them by some non-zero number, because what we're looking for is coefficients to add up to 0. And we either want to do that for x or for y. So what we're thinking of here, in this first example, we don't need to do that step, but I kind of want to show you why we want to do that. It's because what we're eventually going to do is add these two equations together so that the equal sign kind of falls down. And then what we're looking at is when we add those x's together, that turns into 0. That's exactly what we want. One of these has a coefficient of +1, the other has a coefficient of -1. So when we add them together, it turns into 0, which is perfect. So that's what we're looking for here. However, with other cases, like this one, notice if we do that, what I would have is 4x plus 3x, which is 7x, -y plus 4y, which is a plus 3y, equals 48. And now we have an equation with two variables. We don't want that. So when we get to this one, we're going to do some adjusting so that we can get to that point where things cancel. But our ideal is, in this case, we don't have to do anything special because those x's immediately cancel out with each other. And then all we have is a -y plus 2y, which is a +y. And then 1 plus 0 is 1. So we end up with a solution for one of our variables right there. Again, just like our other cases, we're working towards the solution is, and we want a coordinate at the end. We want an xy coordinate. And in this case, we already have our y coordinate. Done. Then to find our x coordinate, we just plug into one of the other equations. So we're at step 4 here with this first example, so solve for the remaining variable. And with that, we just take one of the original equations. Doesn't matter which one. So let's go x minus y is equal to 1, and we're going to plug in y equals +1. Add 1 to both sides, and we get our x coordinate. And then we could just do a quick check that it in fact works. So let's see, we'd have 2 minus 1 is equal to 1. Yep, -2 plus 2 times 1 is equal to 0. True. So that works, and we have our solution there. So with elimination, we're working kind of vertically with our two equations, and our goal is, in the whole setup of it, is to get one of our variables to cancel out, to have it turn into 0. So that's what this part means, is that we want to work with it so that the sums of the coefficients is 0. So like 1 plus a -1 was 0 for the first case. Now with this case, 4 plus 3 is 7, -1 plus 4 is -3, so we're kind of stuck there. So we have to go back to the drawing board and start over. Either I want to make it so that if I add up the coefficients of x, it turns into 0, or coefficients of y. Now I'm leaning towards y here, and that's because 1 is already negative and 1 is already positive. We could do x's and we'd get to the same answer. I'm just kind of giving you my thought process of things that can save us some steps. So we have a +4y, so what I need is a -4y right there. So do that, I need to multiply by 4, but we can't just multiply y by 4, we have to multiply everything by 4. So what we're going to do is multiply both sides of that first equation by 4 to get our new equation. So let's go ahead and move that down here. So on the left-hand side, that 4 is going to distribute. So we're going to have 16x minus 4y is equal to 88. And just be so careful that absolutely everything gets multiplied by 4. And then we're leaving the other equation alone, because now we have our negative 4y and our positive 4y. So when we add these together, we'll have 16 plus 3 is 19, so we'll have 19x. Drop down the equal sign. Negative 4y plus 4y is 0, which is exactly what we want. And then 88 plus 26 is going to be 114. And we will divide both sides by 19 to solve for x, which is going to be, let's see, 114 divided by 19, 6. All right, so again, working towards the solution is, and we have our x coordinate. We still need our y coordinate though. So with that, we're going to go back to one of our original equations. And when I say original, I mean how it was printed on the paper. We want to make sure we don't plug into things that have changed. Like I don't want to plug into that 16x minus 4y equals 88, because what if I made a mistake there? If I could kind of repeat my mistake and it would kind of make it look like I didn't make an error if I did. So what we want to do is go back to a printed form of the equation. So let's go with the 4x minus y equals 22, but now we're going to plug in x equals 6. So we have a 24 minus y equals 22. Subtract 24 from both sides for negative 2. Make things positive, so y equals positive 2. All right, let's check that answer, but let's use Desmos this time. Let's go to that graphing calculator and grab 4x minus y is equal to 22, and 3x plus 4y is equal to 26. And there's our coordinate, 6, 2. Perfect. All right, let's look at 2 more examples here. So what I'm doing is looking vertically. So I have 4 plus 2, which is 6, and 5 minus 3, which is 2. So I need to make some adjustments here so that things could cancel. Let's go ahead and look at what if I didn't use the plus and minus to my advantage here. Let's say I wanted to focus on canceling out these x values. So we would need the numerical values to both be 4. So I would need to multiply by 2, but also one has to be positive and one has to be negative. So while I'm multiplying by 2, where that's going to make a positive 4, let's go ahead and actually make this a negative 2 so that it'll change the sign. So we'll have that 4x plus 5y equals 3 is staying the same. But then down below, we distribute the negative 2, so that'll be a negative 4x plus 6y equals negative 14. And then we're going to add them up. So 4x minus 4x is 0. That's perfect. That all cancels out. 5y plus 6y is 11y equals 3 minus 14, negative 11. Divide both sides by 11, and we're getting y equals negative 1. Okay, so the solution is, and we have our y coordinate of negative 1, and I just need my x coordinate. So let's go to the 4x plus 5y equals 3, but we're going to plug in negative 1 for y. So 4x minus 5 is equal to 3. Add 5 to both sides. Divide by 4, and we're getting x equals 2 out. And let's just do a quick check of the solutions there. So 4x plus 5y equals 3. and 2x minus 3y equals 7. And we're getting an intersection point at 2, -1. Perfect. Okay, let's take a look at this one. So, what do we want to cancel out? Let's go with the y values. What I'm seeing here is a 4 and 6. I can multiply both of those up to a 12, and then I just need to make sure one of them is negative and one's positive. Doesn't matter the order here, but we're going to need to multiply both. I'm going to multiply this top equation by 3. So then I'm getting a 12 out. For where I have 4y, I want that to be 12y. And then where I have 6y, I want that to be 12y. So I'm going to multiply by 2. And then let's go ahead and make that a -2 in order to get some negatives in there. Okay, so up top, distributing the 3, we'll have 18x plus 12y equals 30. And then distributing the -2, so -18x minus 12y equals -30. And now we'll go ahead and add it together. However, something happened here as I was all focused on y's canceling out. That turns into 0. This also turns into 0. So we end up losing our variable, both of the variables, and we just have 0 on that side. And on the other side of the equation, we also have 0. So let's see what's happening in terms of the graphs, because we no longer have a variable to solve for, and we need to see what's happening. So 6x plus 4y equals 10, and 9x plus 6y equals 15. And actually, if you even saw when I had 1 in there, you can see how it's separated. But then as soon as I completed it as 15, it jumped and it's on top. We're getting the same line out. So basically, in terms of solutions, any coordinate that's landing on this line, or really either of the lines because they're the same line, is a solution. So what happened here is our variable disappeared and we ended up with a true statement. So what that means is infinitely many solutions. And in fact, the solutions can be mapped by either equation of the line. Doesn't matter. We could just say, like, for x, it's defined by 6x plus 4y equals 10. That's mapping all of our solutions. Or we could use the other equation, 9x plus 6y equals 15, same thing. But we're getting infinitely many solutions out because they're landing on top of each other. Now, when we looked at graphing, we saw how parallel lines ended up with no solutions. That's our other special case. And what would happen is in solving, we would end up with this case where our variables disappear and we end up with a big 0 on one side. But in adding those together, maybe we would have 5 or some numerical value so that we would be ending up with a false statement. If that happens, then our answer would be no solutions. But in this case, we end up with a true statement, so we have infinitely many solutions. All right, so those are all of our methods for solving systems of equations. We have graphing, substitution, elimination. Really, we're going to emphasize using substitution and elimination because we can get to exact answers there just in case the graph is unclear. And really, it's up to you of choosing which you prefer. And in certain scenarios, I kind of switch between substitution's nice sometimes. Elimination can be nice for some scenarios. You'll just kind of see what fits best for you.